Okay. Hello, everyone. Today we're going to look at our section 10.3, which is about defining and using probability. And so probability hopefully is something that you've been exposed to in the past. And when you've talked about probability, hopefully you've talked about the fact that probability is always between 0 and 1. You can't have a negative probability or a probability that's more than 100%. And probability indicates, essentially, it indicates the likelihood that an event will occur. And when we talk about theoretical probability is like when we talk about the probability of something where we kind of like know how many favorable in total there are. So theoretical probability is when we take the number of favorable outcomes and we divide by the total number of outcomes. And you'll see what I mean in a minute, but whenever we talk about this idea of probability, we're always going to divide by our total. So in probability, we take our favorable and we divide by our total. When we talk about probability can be a reduced fraction. It can be a decimal, or it can be a percentage. So we can express it in several different ways, and often I'll tell you which way that we would want it expressed. But I always start with a reduced fraction unless it gets super crazy, and then maybe you'd want to turn it into a decimal or percent. But we'll practice all of those different ways today. All right, so let's find the probabilities of different events. We're going to use a standard deck of cards. We're going to find the probability of the following. We're going to find the probability of selecting a jack, and then of selecting a red king. So if you get out your probability sheets, so let's go look at selecting a jack. So selecting a jack, what we want to do is we want to take however many jacks there are over our total. And again, we always do total because we're dealing with probability. So if we think about the number of jacks that there are in a deck of cards, we can pull that out and see that there are 4 jacks in our deck of cards. And there are a total of 52 cards that we are choosing from. So if we reduce that fraction, we can divide each of those by 4, and we get 1 out of 13, and we'll just leave it like that. Now let's find the probability of selecting a red king. So that means that our favorable is a red king, and we're going to divide that by our total. Again, we always divide by our total when we're dealing with this idea of probability. And if we look, we can see that there are only 2 red kings that exist out of 52 cards. We can divide each of those by 2, and we get 1/26. And so that's kind of how we can do this simple probability, all right? And again, the theoretical probability is simply referred to as the probability of an event. So probability is theoretical probability. I wouldn't worry about it at all. So let's look at something called odds, all right? Now, odds is a little bit different. When we talk about odds, we don't compare to our total. When all outcomes are equally likely, the odds in favor of an event A and the odds against an event A are defined as follows. So the odds in favor of event A are the number of outcomes in A, but notice that now we look at the number of outcomes not in A. So it's not to our total. Now, if we have odds against, that means that in our numerator we have the number of outcomes not in A over the number of outcomes in A. So usually with odds, so that we don't get it confused with probability, instead of using the fraction symbol, what I'll do is I'll use this colon symbol. And I like to think about it as the number of favorable outcomes, not compared to the total, but compared to the other outcomes. And then that means that for odds against, that you would basically flip that. So you'd have the number of other outcomes, and then you would compare that to the number of favorable outcomes. So I want us to notice that odds means that we compare not to the total, but to the other. Odds, other. They both begin on O, so that's kind of something that we can do. And when we have this colon, it's not, and that's why I like to write the odds with a colon instead of the fraction, because a lot of times when we see fractions, we think that it's this much out of the total, and that's not what odds is. But this is read to, like the word T-O. And so it's basically going to be the number of favorable outcomes to the number of your other outcomes for odds in favor. Odds against, the number of other outcomes to the number of favorable outcomes. And one thing when you have the odds, just like the probability, is that you're always going to reduce. So if you have the colon, which I will always write my odds with the colon, you still want to reduce as if it was a fraction. We're just trying to differentiate between the probability and the odds. Okay. So example 2, tell this is an old example, says Miss Lang either assigns bookwork, worksheets, or no homework every night. Of every 30 days, she assigns bookwork 20 of the days, worksheets 9 of the days, no homework 1 of the days. It wants us to find the odds in favor of Miss Lang assigning no homework. Okay, so now odds, again, means that we're going to deal with other, and odds in favor means that whatever they're talking about is going to be in our numerator. So the odds in favor means that this no homework is going to be in the numerator. And odds means that we compare that not to the total, but to all of the other possibilities. So if we look through the problem, how many times was there no homework assigned? Well, 1 of the days. And then we want to look at all the other possibilities. So we had 1 day where there was no homework. So that means that there were 29 other days of the 30. So we have 1 over 29. We'd reduce that and write it as odds so that we can read it 1 to 29. And that way we know that 29 is not the total. It means for every time there was no homework, there were 29 times where there was something else. Because Miss Lang is mean. I'm kidding. Okay. Letter B. So this time we want to find the odds. That means we're going to do other. Odds against Miss Lang assigning bookwork. So odds against means that whatever they're talking about is going to be in the denominator. So notice that we're looking at odds against bookwork. That means that we're going to have bookwork in our denominator because it was odds against. And because it was odds, we're comparing that to the other. So let's look at that. Let's find the number of times that Miss Lang assigns bookwork. She assigns bookwork 20 of the days. So for bookwork, we'll put 20. Now that means if there were 30 days, if 20 of them were bookwork, that 10 of them were other. And then we'd reduce this to make 1 over 2. And so people don't think it's 1 out of 2, we're going to write it as odds with a colon. 1 colon 2. That means 1 to 2. That means every time that there was bookwork, or sorry, there was something other assigned, there was bookwork assigned twice. Letter C wants the odds. So again, that means we use other. And then in favor, that means we use our numerator of Miss Lang assigning worksheets. So in favor of worksheets means that worksheets is going to be in the numerator. And odds means that we're going to compare that to the other. So let's look. How often were there worksheets? Well, it says that there were worksheets 9 of the days. So that means if there were not worksheets 9 of the 30 days, that means that the other days, there was 21 other days when there was something different. And so then we would reduce this. We can divide each by 3. And then because it's odds, we write it as odds 3 to 7. And that's what odds look like. So look at the difference between probability and odds. Probability is written, for example, as a fraction, and we compare it to our total. Odds is written using the idea 2TO with a colon, and we always compare it to the other. So here's a you try question. It says you have an equally likely chance of choosing any integer from 1 through 30, and it wants you to find the following. Because you're probably not going to pause the video and do it, I guess we'll do this as a we try. And it wants the probability that a factor of 16 is chosen. Well, notice, first of all, we know that this is probability. And because it's probability, that means that we're going to be dividing by our total. And this wants the probability that a factor of 16 is chosen. And in probability, what we want is always in the numerator, and the total's always in the denominator. Now, you guys remember what a factor is. A factor is something that multiplies to make that number. So a lot of times I'll just start listing the factors of 16. So we have 1 is a factor of 16, 2, 3 isn't, 4 is, 5, 6, 7, 8 is. And then when I'm listing factors, as soon as I find the 2 that match, then I kind of start working towards them. So 8 and 2, and then it would be 1 and 16. So these are factors of 16. And notice that there are 1, 2, 3, 4, 5 of those. So there are 5 factors of 16 out of 30 total numbers. So from 1 through 30 means that we do have 30 total numbers. And probability means we divide by our total. So we have 5 out of 30, which is 1 over 6. And probability, we leave it as a fraction. Our answer is 1/6. Number 2 is the probability that a perfect cube is chosen. Well, I know probability, I'm always going to divide by my total. And this time I'm going to look for a perfect cube. So let's think about some perfect cubes. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. Oh, that's too big. So notice that as far as perfect cubes from 1 through 30, there are only 1, 2, 3 possibilities. So that means I'm going to have 3 perfect cubes, and then there are a total of 30 possibilities. And then we can reduce that fraction. Divide each by 3, we get 1 out of 10. And probability we do leave as a fraction 1/10. Okay. Number 3, we have the odds against choosing a factor of 16. Oh, odds means that we're going to have other. And this is odds against, which means we're going to have something in our denominator. And it says odds against choosing a factor of 16. So that means I'm going to have the factors of 16 in the denominator. And odds means that my other will be in the other part of the fraction. So let's think about those factors of 16. Well, we found those above, right? A factor of 16, we said, was 1, 2, 4, 8, and 16. So that means that there are 5 factors of 16. And now there were 30 numbers total, which means that there were 25 other numbers. So let's reduce that, and that makes 5. But remember that odds, and that's why I like writing it as a colon, with a colon, because 5 over 1, that just doesn't look great to me, you know, because we want to write it just as 5. But because this is odds, we want to write it as a ratio of 5 to 1. And so that's our final answer for number 3. So number 4 is the odds. So we're going to use other. And this is the odds in favor, which means we put it in our numerator of choosing a perfect cube. So again, in favor of choosing a perfect cube means that we're going to have the perfect cube in our numerator. And odds means that down in the denominator, then we'll have the other. So remember, we said that perfect cubes, we had 1, 8, and 27 as possibilities. So we have 3 perfect cubes. And then if we had 30 total, that means that there are 27 other numbers. And that gives me 1 over 9. And to make sure that we know that it's not 1 out of 9, but 1 to 9, it's nice to write it with the colon instead. Okay? And that's a little bit about theoretical probability and odds. All right. So now let's look at the idea of experimental probability. So experimental probability is still the favorable, like the number of favorable over the total, but experimental probability looks at what actually happens. So this says when an experiment is performed that consists of a certain number of trials, the experimental probability is given by the number of trials where A occurs, again, over the total number of trials. We still divide by the total. So example 3 says the bar graph shows how old adults in a survey would choose to be if they could choose any age. Find the experimental probability that a randomly selected adult would prefer to be at least 40 years old. I don't know who would choose that, guys. Sorry. All right, so we want to express our answer in 3 appropriate ways. And we talked about those 3 appropriate ways, but don't worry, we'll remind you. So again, this wants that we want the experimental probability. And so probability, we're always going to divide by the total. And in this case, it wants the probability of being at least 40. well, that someone would choose to be at least 40. Again, I don't get it. Okay. So we look at the idea of being at least 40. So at least 40 means that we're going to be able to choose all of these different pieces here. And so to be at least 40 means that we would add 551, 300, and 238 together. Now, hopefully you trust my math here. And when I added these three things together, I got 1,089. And then we want to divide that by our total. So to get our total, what we'll do is we'll add all of these different pieces together. We'll add all of these up because it didn't tell us what our total was. And it turns out that our total is 3516. Now, one of the ways that we can express our answer is as a reduced fraction. And I understand that this is kind of big. So one thing that we could do is we could reduce that fraction. Your graphing calculator can do that for you. If you take 1089 divided by 3516 and press enter, you get this decimal, right? Which we're going to use in a sec anyway. But if you press the math button and then go to number 1, which is fraction, and press enter, do you see how it reduced the fraction for you? I just think that's super awesome. So notice that the calculator can help you reduce that to 363 over 1172. So that's one way that we could get our answer is a reduced fraction. Okay. So then, let's say I want to return it into a decimal. Now that I keep getting this fraction, you can press math, and then you can go to number 2, which is decimal, and that'll turn it into a decimal for us. And usually, you guys, for probability, we list it, the probability to 3 decimal places. So 1, 2, 3, we have 0.3097, but that 7 tells us to bump the 9 up. So instead of 309, that's going to be 310. So that means that this is approximately equal to 0.310. So that's a second way that we can express it is as a decimal. And then a third way is as a percentage. And as a percentage, all we do is we think about moving our decimal place over 2 places to the right, and we put a percent on it. So we'll put 31.0%. So those are 3 ways that we could express that. 363 over 1172, 0.310, and 31.0%. So experimental probability is really just looking at something that has occurred and then putting that favorable over the total. Okay? All right, example 4, find the geometric probability. It says that you throw a dart at the square board shown. Your dart is equally likely to hit any point inside the board. And this time it asks us to round our probability to the nearest 1,000. Letter A wants the probability of getting 10 points. Again, probability means that we're going to divide by our total. But how can we get a total in this case? Well, when we have a geometric probability, often we look at the area. And so if the dart has to hit a certain part of this, like the area that's part of this, so instead of just putting total for this, I'm going to put the total area. And because we want the probability of getting 10 points, that's going to be our favorable, is the 10-point area. So let's see if we can find the total area. You guys, the total area is going to be the complete area of this dartboard, because it says that the probability is equally likely to hit any point inside the board. Clearly, I'm not throwing because it would end up outside. Okay, so this board is a square shape. That this is 18 inches again. And then so this other side is 18 inches. So that means that the area of our dartboard is going to be 18 squared. And that actually gives us 324 if you wanted to calculate that. Well, now let's look at the area of the 10 point. Now notice that the area of the 10 point, let me just color code this for you so you can see it. The area of the 10 point is going to be circular in nature, okay? And we know that, hopefully, you know that the area of a circle is pi r squared. And so we would want to take the radius and use that. Now notice that this says that each of these is 3 inches, so it looks like the radius of this is 3 inches. So that means that I'm going to use pi times 3 squared. Now 3 squared is 9, so that means that the area of that 10 point part is 9 pi, and then the total area is 324. Now we could reduce this, but notice it asks us to round to the nearest thousandth. So I'm just going to take my calculator and take 9 pi. Do not use 3.14, use the pi key please, and divide it by 324. And let's round to 3 decimal places, 1, 2, 3. The 2 tells me to keep that as a 7, so I get 0.087. So that's my answer for letter A. So now it wants the probability of getting 0 points. Okay, well, probability means I'm going to divide by the total, and it's a geometric probability, so I can use the area. And this time I'm going to look at the probability of getting 0 points. So I want the 0 point area. Well, once again, I know that my total area is the 18 squared, which, I'm running out of room, sorry, equals the 324. But now I want to find the 0 point area. Now, the 0 point area is kind of a strange area, isn't it? Notice that the 0 point area is like this piece here, this piece here, this piece here, this piece here. That's not like a real shape. But what you might notice is that it's the whole square, and then you take out the circular part. So notice that the 0 point area that we're looking at is the whole square minus the largest circle. So we know that the whole square is 18 squared as an area. But let's look at this circle here. This circle is going to have an area of pi r squared, but its radius is going to be 3, 6, 9. Notice that this whole thing has a radius of 9. So that means that we would use pi times 9 squared. And then we can just put that here. So that would be 324 minus 9 squared is 81 pi. And we could simplify that, but it does say to round to the nearest thousandth. And so then I'm going to take this, make sure you put this in parentheses, by the way, so that you divide that whole thing. So we're going to take 324, see that, minus 81 pi, that whole quantity, and then divide it by 324. No, those don't cancel because that's not a factor, okay? And so we look and we get 1, 2, 3 decimal places. That 6 tells me to bump that up to a 5. So that ends up being 0.215. Okay. And then letter C, are you more likely to get 10 points or 0 points? And so we can compare the probabilities. Notice that 10 points, we had a probability of 0.087. 0 points was 0.215. So we can see that this is a higher probability. So we can see that 0 points is more likely. Okay. So in this you try question, again, because you're probably not going to do that, we'll make it a we try. And we'll just kind of review this. So the you try says in example 3, find the experimental probability that a randomly selected adult would prefer to be at most 29 years old. So probability means that we're going to compare it to the total. This is not an area question. And then this one we're looking at most 29 years old. So let's look at that at most 29 years old. At most 29 years old means that we would just look at this part of it right here. Okay. So I would add the 463 and the 1085 together. So when I do that, I get 1548. And then we would divide that by our total. Well, we can borrow that number that we did in example 3. Our total was 3516. And this wants our answer as a reduced fraction. And so that means we can use our calculator to help us out a little bit. So we would take 1548 divided by 3516. And you can press enter and then do the math fraction, or just right from there you can just do the math fraction and then it'll reduce the fraction for you. And that gives us 129 over 293. And that's our answer for you try 5. Then in example 4, number 6 says in example 4, find the probability of getting 5 points. So again, it wants probability, so we're going to divide by our total. And I noticed that this is a problem that involves area, so I'm going to put total area here. And then we want the probability of getting 5 points. So we're going to look here at the 5-point area. Now it's hard to see on here, but the 5-point area is essentially going to be everything in here. And we notice that the 5-point area is like this one big circle here, but it's kind of like we're subtracting off this circle that's in the middle. So the total area, again, we know, is the whole dartboard, is the 18 squared. But the 5-point area, because of this ring shape, is going to be the big circle minus this little circle. So if we look at the big circle, notice that the big circle has a radius of 3, 6. So the big circle would be pi times 6 squared. And the little circle just has a radius of 3, so pi times 3 squared. So I can simplify that to get 36 pi minus 9 pi, which ends up being 27 pi. And then I can simplify 18 squared to make 324. And then it does ask me to round to the nearest thousandth. So that means that I can take this fraction that I have and put it in the calculator. 27 pi divided by 324, and then I just press enter. And I have point, let's see, 1, 2, 3. That 7 tells me to bump that up to a 2. So that gives me about 0.262. Okay. So just two more examples of that. Okay. All right. Lastly, permutation or combination. We can do probability and incorporate the idea of permutation and combination. Remember that when we had a permutation, that order was important, and that if we had a combination, that means that the combination is more of like a grouping than ordering or arranging. Okay. So example 5A says, suppose 15 people qualify for a college cheerleading squad of 5. 6 women and 9 men. What is the probability that the squad of 5 consists of 3 women and 2 men? So it wants the probability, so it wants our total. And our total, instead of writing total here, this is really using any 5. Our total consists of choosing any 5 people. And we want the probability of getting 3 women and 2 men. And so let's think about what we could do in that case. So let's look at this probability of getting 3 women. So we have 6 women total, and we want 3 of them. Is this going to be a permutation or a combination? So when we think about that, let me go this way. 6 women and we have 3 women. Notice that if we have a cheerleading squad, it's like a group of people. Hopefully there's no hierarchy because that would be rude. So we're just going to use a combination. And because we have 6 total and we're picking 3, we're going to use 6C3. Let's do the same thing with the men. We have 9 men and we want to pick 2. So that means that we would do 9C2. And means that we're going to multiply those 2 together. And so we can take 6C3 times 9C2. And now we look at any 5. So when we look at any 5, notice that our total is that we have 15 people total, but we're picking a squad of 5. So our total is actually 15C5. And that's the beautiful setup in number 5A. So it wants us to write it as reduced fractions and decimals. So you can even just put this whole thing in the calculator. 6C3, just make and then times 9C2. Put that in parentheses. And then divided by 15C5. Oh, whoops, sorry. And to 3 decimal places, 1, 2, 3. That 7 tells me to bump that up. It was at 0.2397, so that's going to round that to about 0.240. So that's the decimal part. And again, I could then do math fraction, and it'll turn it into a nice fraction for me. So 240 over 1001. And that would be the probability that the squad consists of 3 women and 2 men. Let's look at letter B. It says the Plymouth bowling team consists of 6 seniors, 4 juniors, 3 sophomores, 2 freshmen. 2 members are able to compete at states. Find the probability that the 2 participants are both juniors. So the probability means we want our total. And again, our total is this idea of 2 members. So that 2 members is what we're choosing. so our probability is going to be choosing any two. But specifically, we wanted that the two participants are juniors. So that's going to be our favorable, is two juniors over any two. So let's look at the likelihood of getting two juniors, or like, I guess, how many different ways you could get two juniors. You have 4 juniors total, and you're picking 2. So that means we're going to have 4 something 2. And if you're on the bowling team, it shouldn't matter. If you're a team, it shouldn't matter the order that you choose. So that's going to be a combination. Now our total is going to be any 2. So we look at our total. We had 6 seniors, 4 juniors, 3 sophomores, 2 freshmen, no partridge in a pear tree. But we have 6 plus 4 plus 3 plus 2. And that gives me a total of 15 to choose from. So I have 15, but of those 15, I'm choosing 2. So my denominator there is going to be 15C2. And so then I'll take 4, I guess I don't need the parentheses, 4C2, and then divided by 15C2. And if I look here, 1, 2, 3, 1 tells me to keep it. That tells me that I have 0.057. And then I can math fraction it. And I can see that that also reduces to 2 out of 35. Okay. Last one, there are 5 starters on the basketball team. They're announced before each game and the order is chosen randomly. What's the probability that they're announced in order from shortest to tallest? Or sorry, tallest to shortest. So again, probability wants the total. And this time, we're looking at an order, any order. And order is really Q for, that's right, a permutation. And we're looking here at the probability of going tallest to shortest. So notice that they don't give us any indication in the problem about tallest to shortest, but I want you guys to think about it. How many ways are there to arrange things from tallest to shortest? Well, there's just one way, right? You've got the tallest all the way down to the smallest. There's just one way to do that. And as far as the order, there are 5 starters total. And we're announcing them. And how many of the starters do you think they're going to announce? I would think they would announce all 5 of them. And again, because it's the order that's important, we are actually going to use a permutation in this case. So we're just going to take 1 over 5p5. So 1 divided by 5p5. As a decimal, we can see that gives me 0.008. Oh, sorry, 0.008. And as a fraction, that gives me 1 out of 120. Okay? So there's a lot of stuff today, wasn't there? We talked about a ton of different things. We talked about, we talked about the idea of probability in general. We looked at the idea of odds and how those should be expressed. We looked at experimental probability. We looked at using areas to help us with geometric probability. And then we also looked at using permutations and combinations to help us in probability. So this was a pretty huge lesson. So hopefully you guys can do well on the worksheet, and then we can talk about it during the review. All right? Thanks a bunch. Have a great day.